Alright guys, welcome. This is our review video. The 4 questions I'm about to do are going to be the same 4 questions you're going to do on your tests, essentially. So make sure you guys follow along, write down these notes, we'll check them for tomorrow. Here's our solution right here, and our system, sorry. X plus 2y equals 11 and 3x minus y equals 12. And I'm asking, is this right here the solution to this system? Basically, if I were to graph this, is this where these two would meet? Remember, it's always the x first, then the y. To do this, I'm going to go ahead and plug into my equation and see if this is true. So we got to first plug into the top equation and see if this holds true. So I'm going to rewrite the equation. I suggest you do as well. And we'll plug it in. So we get 1 for x plus 2, and we get 5 for y equals 11. This is going to be 1 plus 10, and so 11 does equal 11. So this works out for us. Once I do this, I got to make sure it works for the other equation too. So let's do the other equation. We have 3x minus y equals 12. And I'm going to plug in 1, so I get 3 times 1 minus 5 for the y equals 12. This is 3 minus 5, and I get negative 2 equals 12. This does not work. If they were both worked, if they both ended up, 11 equals 11 and over here 12 equals 12, then this would be a solution. In this case, this is not a solution. So you have to have them work for both. So essentially, you're going to be plugging in the x and the y value, so the x and the y value into both equations and checking. Next, we want to go ahead and graph. These are two equations that we can graph. Remember, we graph by using y equals mx plus b. M is my slope, that tells me how to move, and b is my y-intercept, and it tells me where to begin. So let's go ahead and start with a nice big graph. And I'll put some numbers on here. Now you're going to have an actual graph on the test, so you'll be a little bit more precise than me, and if you need to use a ruler, you can. Mine might not be quite as precise. We'll go ahead and graph the first one. I'm going to graph it in this dark blue. Okay. If you can see here, there is no b. There is no b. That's kind of confusing that I wrote that right there. Let's look right here. If I did plus 0, that would technically be my b if it lines up with this. So I'm actually going to start right here at the origin. Okay. My y-intercept is 0. My slope is actually 1 over 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And you're going to kind of see that I'm going to get this essentially diagonal that cuts right through the origin. Something that looks about like that. My next one I'm going to use, let's use green. My b is positive 3, so I'm going to go up 1, 2, 3, and there's 3. And my slope is negative 1 over 1, so I'm going to go down 1 over 1. Oops. So it's down 1 over 1, down 1 over 1. My goodness, really hard to do this with this thing. Okay, and our line's going to go through there. The question, where does it meet? It meets right here, and it's kind of hard to see. That's at 1, 1, and then it's at 2, 2. This one doesn't meet perfectly. The one on the test will. But if we look very carefully, it's actually meeting in the halfway between. Yours isn't going to be as bad as that, but we want to pick the point where it meets. Let's just say it met at 1, 2, even though it didn't, but that's approximately where it looks like it is. They will be whole numbers for the ones that you have and where they meet. Again, hard to do on the graph when we don't have a perfect graph. Alright, we want you to demonstrate how to solve a system by substitution. Okay? And on the test, one of them is already going to be solved. Notice y is already solved. It equals x plus 3. So what I'm going to do is I'm going to take this, I'm going to substitute it in for the y into the other equation. So when I do this, I'm going to end up with 2x plus, and instead of y, we're going to go ahead and substitute in what y equals, which is x plus 3. And that all equals 9. Now the key to this is to make sure now we have an equation with only one variable, which we do. So we get 2x plus 3 equals 9. I'm going to go ahead and combine these like terms. So that gets me 3x plus 3 equals 9. I'm going to subtract 3, and I get 3x equals 6, divide by 3, and x equals 2. Now that's one of my parts of the solution. Again, my solution is going to be an x comma y. I know my x is 2. The y part, we need to plug it back into one of the original equations. These are my two original equations, right here and right here. So I'm actually going to go ahead and take this top one because it looks the easiest. And instead of x, we're going to plug in what it equals, which is 2. And this makes it pretty simple. 2 plus 3 is 5. So those are my two answers, and then we have to write as a solution. And we always want to remember that we put our x first because it comes first in the alphabet, and then the y. Okay, so substitution, we sub it in, we solve, and then we sub it back in to find the second variable. The last one we're going to have is an elimination. An elimination one, we want to make sure everything's lined up first and that we have opposites. Notice this is a positive one, this is a negative one. If I were to add these, they'd go to 0. So I can add them. These are going to go goodbye. Notice I have 2x and 2x. A lot of students might want to say those go to 0, but since I'm adding, 2 plus 2 is not 0, it's actually 4. And 10 plus 16, or 10 plus 6 is 16. Go ahead and divide by 4, and we get x equals 4. It's very important that we take this very slow and systematic. I have my first part, which is 4. I want to find the y. To find the y, I got to plug it back in one of the original equations. I'm going to plug it into the bottom equation, which is y plus 2 times 4 equals 6. This is going to be y plus 8 equals 6. Subtract the 8, and I get y equals a negative 2. So my final answer is 4, negative 2. Thanks for watching the video. Go over them a couple times. These questions are identical to the ones you're about to see. So if you know how to do these, you're good. Alright guys, we'll see you later.